quite funny that I will talk about being framework agnostic while working in the company that is so tightly coupled in Magento. Actually, in two Magentos, Magento first and second one. Okay, but just to start, let's go through a quick overview of PHP frameworks, maybe more. Okay. Okay. So, oops. Oh, okay. Okay, history. How many PHP frameworks do you know? 5, 10, 20, lots of them. There are actually lots of them. And let's go back into 10 years. The most popular ones of those days are Symfony 1, then Framework 1. 1, 2, 3, 4. That's better? Yeah. Okay.
Should we start from scratch?
We're good.
Okay, sorry about that. We've got CodeIgniter those days, and Magento 1 was released almost 10 years ago on top of then Framework 1. And speaking of today, every single framework from those days is really dead now. Now we have Symfony 4, which last complete rewrite with almost 8 years ago. We have Zen Framework 3, Magento 2, Laravel, which is a new star, and it's just a bunch of Symfony components with flavor of Ruby on Rails. And now, era of micro frameworks started. We have Silex, Slim, actually really 1,000 of them. And what we can talk about the future, what will happen with those frameworks in 10 years, actually, not precisely, we cannot predict anything else that every single nowadays popular framework will be dead. And this talk is about what we would do with this fact that everybody dies, including frameworks. Okay, the first option how to deal with dead one is try to reanimate it, maintain it, its infrastructure yourself. That was what I was doing for Symfony for 4 years. We had to fork almost every community plugin we needed to use. We created Composer plugin, we created a plugin to install Symfony's plugins using Composer. It was really lots of job, but we had to do it just because all our application code was tightly coupled with Symfony 1. And it wasn't that easy to re-implement all the stuff on top of Symfony 2, for example. The second option is just don't care, that one is still one. That is what I did in my another previous job. We started application on top of really ancient framework. It was obsolete even when we started. Oh, that's much better actually. I can hear myself. Okay, what I was talking about dead ones. Okay. This one was really dead. It was super old, but I actually don't know why they started an application on top of it. I joined a bit later, but it was the fact, the thing which we should work with. It was really old. It was full of singletons and this messy spaghetti code like everybody writes in his first days. Yeah, it was really amazing. But what I started doing there, I started just grabbing cool components from Symfony 2, which became matured this time, and one component from Laravel, and I built the whole Frankenstein from those components just to ease my own life. But I realized that I made the life of other developers a bit more hard, because they now need to learn all those new things. And after that, I just started counting, and I think it would be maybe less expensive for the company not to build this Frankenstein, but re-implement the whole thing, which is the third option. This one is dead, give me another one. That is usually funny for us as developers. Every developer, I think, wants to re-implement the whole application he works on, just because now he knows better how to start it, because of his experience working on it. And maybe you mentioned that all three options are not good at all for the company, actually for everybody who is involved. And is there any way to avoid this? And yes, there is a way, and this is what my talk is about, actually. And let's start from a bit of example. The task is pretty simple. We need to create a feed of products available in our store and send it via FTP as a CSV document. It's pretty easy, pretty straightforward with the action from 3 steps: fetch list of products, then convert them into a stream of CSV, and then just send it. The code is this simple. I don't want to reinvent those wheels, so I just grab a CSV library from League, just use a Magenta products repository, and just use a Magenta bundled FTP client, which has this pretty strange name. I use dependency injection to inject all of those classes into the class. And the whole action is that simple, only 3 lines. It's pretty cool, pretty straightforward. It's easy to read. My code is clean. My life is beautiful. You know, I just solved the use case of the client with only 3 lines of code. But
and you did it with PowerPoint.
Yeah. Okay. But the problem is that what I actually did, I created a tightly coupling between my use case, which is just products export, to this FTP thingy. I don't know how it works, how it should work, how often it changes, but I have this tightly coupling, and it is still okay in this small schema, but the problem is that almost every single project has many of those exports. For example, we have an export with to client's ARP, to recommendation system that will recommend users something to buy. And so that we will end up with lots of those classes, and all of them will be dependent on this FTP class, which is not that cool now, because what if I told you, oh no, now you're just trapped with this dependency, because it's started being not that easy to change it. It will be lots of places when you need to change only one thing. And what if I told you that FTP is not good enough as a transport protocol? You have a secure FTP now, which is much more secure, you know. So, okay, there is a solution for it. It's called dependency inversion, and it is a part of Solid. Maybe you know what Solid is.
Who does know what Solid is?
Okay.
Okay. Should be way more advanced.
Yeah, probably. Okay, the idea of principle itself is quite easy, and the idea is to split your task, your module, into several layers, into several layered submodules, and define relationships between those layers. And the first part of these relationships is that easy. High-level modules should not depend on low-level modules. Both should depend on abstractions. What it means in our case that we have FTP, CSV writer and repository as low-level modules, and our use case as a high-level. And the problem is that our module directly depends on low-level modules, like FTP, for example. I will talk about FTP more. So it's time to fix it. That is a class diagram of the implementation of this fix. We introduced this FTP client interface, which is a part of the module now. We have this Magento FTP client, which is just an adapter for Magento FTP thingy. So our module now contains of those export classes and FTP client interface. The most important thing in this schema actually is this arrow between Magento FTP client to FTP client interface. As you can see from directions, there is no direct way from export classes to FTP and vice versa. And that is dependency inversion is all about. Okay, exactly the same thing in code looks like this, just pretty straightforward interface with only one function and class Magento FTP clients that implements it. That's pretty straightforward, easy. But now we just decoupled our third party from our use case, from our application logic. That was the thing we tried to achieve. And the next part is about naming. Actually, abstractions should not depend on details. Details should depend on abstractions. It sounds messy, but actually it's all about naming. Naming matters here. And what it means that the name of our abstraction of this FTP client interface, I called it previously, should be explicit enough just to define what the implementation of interface should do, but should not be that explicit to restrict implementation. It should not contain any implementation details like FTP client. FTP is implementation detail. Our product expert don't want to know how this content should be delivered. Only thing it needs something to deliver. So, for example, transport interface is much better naming, because what actually this class needs, only transport, only something that delivers your content, and that's it. So I renamed transport FTP client interface to transport interface and Magento FTP client to FTP transport, just for consistency. The same thing in code looks like this, almost the same as previous example, but with a bit different naming. Which is what is not clear from these slides probably, that this interface, transport interface, is a part of your module namespace, not something else, not Magento, not some adapter or third party or whatever. It's a part of your application. That's really important. And that means that we are actually finally free from one of our dependencies. I don't repeat the whole process for two left. So it's time to go to next level, which is generalize the concept from module level to the whole application. And there is another concept, which is hexagonal architecture. It was introduced by Aleksandr Panshin almost 15 years ago, and usually it sounds like this. I will read it. Create your application to work without either UI or database, so you can run automated regression tests against the application, work when database becomes unavailable, or just switch databases, and link applications together without any user involvement, which basically and usually is illustrated like this. I don't know why hexagon actually, but maybe I have an answer for this question, but I don't know why Aleksandr chose hexagon, but that's it is the application is your domain logic, so your classes, your repositories, your logic, business logic of your project. This adapters layer is very thin thing that just encapsulates application from framework and vice versa. And framework encapsulates all in layers from wild internet, as I call it, and I mean every single thing you just don't want to be aware of while developing applications. Some databases, file systems, HTTP itself, everything. You just don't need it to model some business process. You can imagine framework as another boundary, like if you have an application, you can imagine framework as a boundary of this application, like exactly the same way like databases, like file system, like almost every EO. Basically, it just provides you a handful of tools to abstract from those things and request-response machine. That's it. Framework is just a layer, not a thing that you should use in your code directly. And as an example, that is, do you know Symfony? Who knows Symfony? Okay, that is pretty simple and pretty straightforward Symfony controller. We have only 10 lines of code and we have 4 dependencies here. It extends a Symfony-based controller. It gets a request class from HTTP Foundation component, and it uses doctrine to get some documents from database, and it uses templating just to render a template. Those dependencies are wrapped in this render function and this getDoctrine function. But actually what it needs only a way to get users from the database or whatever, and it needs a way to render stuff, nothing else. So we can rewrite it a bit, extend from our own controller just to get a bit off from framework, which we don't use anymore in the code. Inject users repository, which was extracted from Doctrine. It's just an application level repository that uses Doctrine inside, but don't allow you to talk Doctrine directly. And this engine interface is what is hidden by this render. So our function becomes much shorter. It just finds active users from a repository and sends it into a template, which renders a response. That's it.
Question: what object does this render response returns? Should return your own class then? Yes.
Yep.
So it's referred to, because it should inherit the framework's class, so you can change it later.
Yeah, I will talk a bit about it a bit later, but as for now, it's enough that we use a framework only as a request-response machine. We get request and create response, and that's it. We can abstract of it too, but I will talk about it a bit later. Okay, so being agnostic about whatever out of your boundaries gives you amazing freedom of choice of implementation, those details. You can switch from one database to another. You can switch from MySQL to MongoDB, for example. You can switch Doctrine to Propel if you need really, but I don't like this idea actually. But it requires trained common sense. Sometimes you just don't need it, and frankly speaking, you almost, not always, but often you don't need it. But if you have a really huge application, this abstraction matters. And to sum everything up, I will try to formulate those principles of being framework agnostic. And first one is explicitly define your boundaries. They call it hexagonal architecture. The idea is what I was talking about a couple of minutes earlier. Just define boundaries from your application and guard them. Examples of those boundaries are file system, database, time. Almost every developer forgets about time. That time is a boundary too. Like for example, if you have ticket selling system, and you need expiration time for them. And if you want to test it, if you want to test that ticket really expires in 10 minutes, your test don't want to wait for 10 minutes. You need a clock to move arrows, and that's it.
End of month.
Yeah.
Are you going to really wait for end of month?
Yeah. EO. Every EO is a boundary. HTTP is just an EO, and it is what you was talking about, that I personally tend to abstract from HTTP request and response in my controllers too, because and move all this conversion logic into another layer just to get request module, which contains only the data I need in this controller to pass deeper in my application. And so I usually prefer to return some object, not a response. And you can imagine other parts of your domain logic as boundaries as well. And when you define those boundaries and you implement those adapters between these pieces of your application, it's much easier to manage the application itself. It's much easier, for example, to split your Behemoth application into microservices. You just need to re-implement those interfaces via HTTP, and that's it. So if you have a Behemoth and you don't know how to split it into microservices, just hexagon it first. It will help. The second principle is rely on abstractions, not on implementations. They call it dependency injection. And as an example, I will return to this FTP client interface and transport interface. This one is much better just because of naming. It's more abstract. It does not reveal any implementation details, just because if you, for example, if you want to send this CSV document as an email, it would be quite interesting thing that class email implements FTP client interface. It even sounds disgusting. But class email implements transport interface, sounds okay. That is thing. Another thing is depend on only what you need, really. They call it common sense. And as an example of this, we can again return to this thing about products export. And when we started, we injected products repository directly, which is a really huge class. It contains almost 1,000 lines of code, but we need only one piece of this, only one tiny function, get list. And I always prefer to extract this logic into a separate class, create my own products repository, extend or inject original one, and then create a function that will do exactly the same thing, but this class will now be in my domain logic. It will just use Magento, and it will reveal only what are the parts of the module need, not the whole repository.
Sorry, you mentioned the extension, the parts that you need, but your example doesn't...
Yeah, I agree. It was my mistake. I'm just a bit nervous. You don't want to extend something, almost always. This thing is almost only PHP related. If you guys work on Java or another compiled language, you just don't know about it anything. Just compile it don't allow you to do it. But in PHP we can break interfaces. Like we injected an interface into some class, and we know that implementation of this interface has some more public methods in it, and we can just use them without any warnings, notices from the language. Please just don't do it anymore, ever. Because what you are doing here is you discovered that abstraction behind this interface you injected is leaky for your code, and you're hiding this discovery, which is usually good for your application, because if you have leaky abstraction, you have an option to improve it somehow. And if you don't, you will just leave it as is, and it will, maybe sometimes it will spoil your life a bit later. For example, when you start re-implementing this interface, again inject another class, and then you discover that, oops, I needed this function, and it could be quite problematic for you. And that is actually it, what I wanted to talk about you. That is a reading time section. I usually create those slides like the first link is a list of Uncle Bob's papers about object-oriented design, including Solid, which I think almost every developer should know what it is. And the second link is an article to Alistair's article about hexagonal architecture itself. It's written in quite complicated language, but the most useful thing in this article is the last one for the reading section. He has really lots of interesting links in this article too. So that's it. Thank you for your attention. Do you have any questions?
Solid is cool.
Yeah.
What if I tell you that the regular lifetime of an application is around 5 years? So it's totally fine, depending on the libraries which will die, its applications will die.
The problem is that you don't know when your framework will die.
Like, you can support it like for 1 or 2 months, because the point is I was working once in a project where hexagon architecture was in like, in Zillion grade.
Yeah.
And you have to go through 6 interfaces until you get to the target piece. And if you need to change, add some form, you just go there and it's so frustrating. Just, it's a good idea, but like sometimes it gets really obscure. And people just read the book and say, and now I got it. Interface.
Yeah.
That's an answer.
That's why I told that almost always you just don't need it. You need it only in really huge applications.
That wasn't small. And how do you decide once you need it?
That's a good question. And it's a matter of common sense again.
Everyone has its own habits, like how you decide.
Yeah, I usually start writing the code from tests or from interfaces, and then I delete unused ones. By unused, I mean the interfaces that has only one implementation, and there is no stub for this interface. So if you have this video implementation, you just don't need an interface.
But in order to write tests, you still need to provide interfaces.
Usually, but not always.
But well, more often than not. Or
if it is your boundary, again, you need you need an interface.
Stub it out. In order to stub it out, you need to provide interface.
Yeah, but if this thing is not a boundary of your domain, you can just provide object. You don't need mock it. You don't need to create a stub.
Yeah, that kind of work. Any more questions?
Everything is clear.
Aleksandr made it so clear.
Thank you.
Let's ask one question to the audience. Who uses this principle at work? Solid? I mean, like Solid as described by
Inversion of control or dependency inversion. Good for you guys.
Who doesn't? And why? Can you explain why?
Can you explain why it's needed? Functional programming. I couldn't figure out why it's needed. Measure the cases. Okay.
Imagine you now need to send over your reports not via FTP but via email. or put them to Amazon S3. So then basically you need to change every part of application where this logic is executed. That's why.
I know, I've been using it in another project, but it was used all over the place, like to the extreme. So I used it enough, so I know how it works. The question is like, do you need like most of the time? You can use it without it. Because if you have too much inversion of control, the difficulty is understanding which interface, as I was explained, is used, where is a good implementation is. Because if you have too many abstractions, it's difficult to find.
That's another point Kirill explained, is that like the truth is where common sense is, so it's somewhere in between as usual.
Yeah.
But that's a really good point. Thank you, Aleksandr.
Yeah, for discussion.
Yeah.
That's a good thing for discussion.
Yeah.
Yep.
Give me a second.
I have a question.
Yeah, another question, please.
Yes.
What agnostic is all about here? In my opinion, agnostic words relates to religion.
Agnosticism is a term, is actually about you accept something, that something exists, and you don't need details. Okay, it exists. I'm okay with it. That's why that is how you are okay with framework. It exists somewhere around your application. That's why agnostic.
You are not reliant on the system. It's not your truth, and you don't give a shit if it's replaced. It's just your open free being replaced.
So this unfolds the meaning of word agnostic.
Yes.
Thank you so much, Aleksandr.
Thank
That's
you.
for you.
Thank you.
Now we have a short break.